I'm super excited to talk to you about generics. So what are generics? The easiest mental model to understand generics is you can think of them as functions in TypeScript that are similar to functions in JavaScript in the way that functions let you pass in arguments, right? So imagine if we could do the same for variables, so the user can specify their own types. And we're going to go through a lot of examples because I think the really generics are underrepresented in the terms that all the material I've seen just shows one or two examples and then moves on, when generics are something super complicated to wrap your head around at first. Or maybe you get them at first, which is fine, but trust me, we're going to go through a lot of examples and I'm super excited to show you the power of generics. If you remember, one of the first examples of generics we encountered was the promise for the Pokemon fetch example, but another one was the array method. So let's go over that one, because I'm going to show you some interesting things. So we can say Pokemon, and then we can use the generic. So array is a built-in type, and then we can say what that array contains. It contains string, right? So remember, the equivalent for this is string and the curly brackets, but this isn't a generic, right? So we have to use array string, and then let's just define our Pokemon. So you can say Bulbasaur. Oops, let's do it like this, Charmander. And then we can say Squirtle. So one awesome thing I want to show you is where does this come from? So if you remember, as I said, if you press Ctrl or Alt and hold it, you're going to get this pointer and then you can click on the type. But also I believe if you right click it, we can go to definition, right? So we can see this is really familiar, right? So here is the interface for array and it has some really interesting things. So one thing you should note how TypeScript builds upon types. Imagine the first time that we got some of these array methods were like, for example, in ES5 or ES 2015, I think. So you're going to find the first of them here. So if you go to ES5 DTS, you can see here is the interface. Here is all the familiar array methods we might be familiar with. So you can see toString, toLocale, string, pop, push, concat, and then here even is a type to declare the array, which is an array constructor. And the array constructor just really is a global value. It tells you, hey, what types of array this can be. And if we see here, it is the array constructor, and this really isn't important. But let's, for example, look at how, imagine that this is an array function and then we're passing in an argument string, right? And we can see here it's represented by T. This name can be anything, it can be banana. Yeah, so if you look at the interface, for example, let's find one. So pop, you might be familiar with pop or push. You really don't know what you're going to return because you can pass any array. So you can say pop as you define it, and then you can say, hey, you're going to return these items, whatever you passed in, and this is specified by this, right? So it's really like a function. And when you start thinking in that term, generics are going to make a lot more sense. And there's a lot more examples, of course, here. And then, as I said before, let's say, for example, if you go to ES, yeah, here it is, ES 2015, we can see here entries, keys, values. So here only the values that were added for that version, I think. And then here's another thing, this symbol. So let's go to 2016 and you can see what was added here. It was includes, right? And then we can go to 2019. We can see what was added. Flat map, might be familiar with that. Flat, very familiar, right? So let's see what's in this here. Oh, so add, interesting. So you can really learn a lot. Like, this is documentation in your editor, and this is really awesome and something you can dig into. But let's go back to generics, right? Because this really isn't important to us right now. So let me just exit this. So as I said, just as functions, we can pass anything inside here. So for example, as I have in this example, we can say that this is an object, right? Let's just make it more readable. So we can say name is a string, and then we can even have a Pokemon type, which is going to be a string. And then we can change this array example. We can just say that this is an array of objects of Pokemon, right? Like this. Let's also make this a lot more readable, right? And then we can say name, Pikachu, and then TypeScript is of course complaining at us because it has to have the other one, Pokemon type, right? I'm going to give it the lecture, right? And then you can of course abstract this away. You can put this in a type alias interface. But yeah, so if we were to abstract it, we can just create, for example, let's use an interface. You can say Pokemon, and then let me just copy over this part. I don't even need this, so we can just copy it over, and then we can pass Pokemon right here, save, and that's perfectly fine. So let's look at more examples. So let's look at the log Pokemon example and answer why you might use generics. So for example, let's say we have function log Pokemon, accepts a Pokemon, and then let's say it returns Pokemon. So as with anything and any of these things you learn, like, don't worry about when you would want to use something, because when you get into that situation, it's going to be really obvious when you have to use it. A lot of people are paralyzed and think, oh, I have to learn anything because I'm going to use this thing wrong, and there is no such thing. If what you're doing works for you, there might be efficient methods, right? But that's really not important. So when you would use generic is when you don't know what the user or yourself is going to pass in ahead of time, right? So for example, let's say that log Pokemon is any, and this really doesn't give us any type completion, right? So this is really awful. And then we might say unknown, which is, it's like lesser evil. But then maybe we can say, okay, so I know that this is going to be like a singular string Pokemon, or this is going to be like an array of Pokemon, right? And you might be thinking, so far we have to learn that this is fine, which it is, but here is a problem. So if we say log 1, and then we log Pokemon, let's say Pikachu, and then let's create another one, log 2, log Pokemon, and then we can give it an array, Pokemon, Bulbasaur, Charmander, Squirtle. Oops, there we go. Everything is fine, right? Until we try to use any of the methods. So for example, let's say log 1, we want to use 2 uppercase. Not possible. And why is this? Remember what we learned about unions. Both types have to have matching methods. So if we hover over log 1, we can see that the type is inferred, it's a string or an array of strings, and the types don't overlap, so we really can't use any of those methods until we make some checks for it, right? And same as for log 2, which is the same type, because we really can't use map or anything. So generics are really helpful in this scenario, because let me just remove this. So how do we define a generic? So generics are those scary angle pointy boys, right? So we can say whatever here, we can say t as you see in the type, and here we can say whatever. So remember, this is kind of meta, so it's like a function inside a function if you're thinking of generics as functions. So we can say the same thing we passed in, this is going to be the same type, right? And the return type is going to be the same type. But let's use something more descriptive. I really hate using just t because it's really confusing, and you can have also more generics. So we can say, for example, t Pokemon if you want. Use whatever naming convention works for you, right? Alright, so look at this magic. So here is log Pokemon, which is Pikachu, right? So what is going to be the inferred type? It's going to be the literal type Pikachu, which is awesome. So for example, look at this. If we say log 1, 2 string or 2 uppercase, and it works fine because TypeScript inferred it. How awesome are generics? I really love generics. Let's look at log 2. We can use map, for each, whatever, and it's really beautiful. If we hover over the inference, we can see it here. How awesome is this? This is going to blow your mind, I hope. And you can also be more specific, of course, so you can use the pointy boys here, and you can say that this should be a string maybe, and not a literal type, right? And for here, we can say that this should be an array of strings, because you might have an interface, right? Interface Pokemon, right? And then you might replace this with your interface. But yeah, let me just move out to this. I'm going to remove this, so you can see it inferred a string and an array of strings. And this is really awesome. So you can also type this using a type alias, so we can say type, and then we can say log Pokemon. And how would you define this? For example, again, we can say t Pokemon, function body right returns is going to return t Pokemon, and here we have Pokemon again, t Pokemon. So here we need to remove this, and we can't really invoke it because it's not going to work, because it's going to give us an error. If we say log Pokemon, it's going to complain, it's going to say, hey, type string is not assignable to type log Pokemon because you're not using it, right? So you would do this when you need to change the generic type, right? And then we can say log Pokemon, and now when you say log 1, look how this changes real time. So look at the type, it's Pokemon unknown returns unknown, and the first thing when we type, for example, Pikachu, it's Pikachu. Boom! Mind blow. This is honestly mind-bending, and we're going to look at more examples, of course. So let's look at log 2, for example. Let's pass it an array. Look, it changes real time. Oh my god, this is so awesome. I love it. And then if you want to specify it ahead of time, you can move the generic you pass in here. You can move it at the front, and then here is going to complain if we hover, is going to say generic type log Pokemon requires one type argument. So you have to pass it here, what is going to be ahead of time, and then you can say array of strings. So for example, if you pass in a number to log1, is going to complain argument of type number is not assignable to blah blah. And yeah, same for the array, like if it's not a string, if we type true for example, is going to say, hey, type boolean is not assignable to type string. And this works the same for interfaces. So for example, if I go here, we can create interface log Pokemon, and then we can just, yeah, let's just type it, so repetition, right? And then we can say Pokemon, or what did we use? We said T Pokemon, right? Then we can specify the function argument, right? We can say Pokemon is going to be T Pokemon. And yeah, we can say T Pokemon. And that's going to work the same. Of course, this is complaining because we're using the other version, right? Where we have to specify it. Yeah, this is going to work just the same, which is awesome, right? So remember, we didn't specify it, what this has to be. So you can say string, and then it's going to give us an error. Same here. And then if you want to be explicit, you can really move this right here, and then we can do the same thing. So we can say string, array of strings, and then we can remove it here, and it's going to work just the same. And we're going to look at more examples later of this. I just want to expose you to what's possible. But yeah, this is really exciting. So let's look at another example. So in this example, we're going to have a function map that's going to take an array of values, and then we're going to specify a callback. So for example, let's say we pass it Bulbasaur, Charmander, Squirtle, and then we want to pass in a callback, and then let's say for every value inside, let's do uppercases, right? So this is really going to show the power of generics. So first thing you would do is, of course, create a function map, and then we're going to have values. Let's just name it array, right? I'm going to use the full name array, and then we're going to have a callback. Yeah, so let's return array map callback, right? So TypeScript is of course complaining because this isn't typed with anything, and then you're like, okay, TypeScript, leave me alone, I'm not really in the mood today. And this is fine. But then if we go, for example, let's say map, and then it's array any, so you're like, whatever. And then let's make this also easier. Oops, my bad. Let's make this easier. I'm going to say const Pokemon, Bulbasaur, Charmander, Squirtle, just so it's more readable. Yeah, and then we can, again, if we open the function, it says array any. Let's just pass the Pokemon in. And now let's return a callback. So we want to say for every Pokemon, we want to use Pokemon, and then we say dot, and we're sad because we don't get any autocompletion, type safety, anxiety, and our reminder of our own mortality takes over us. So if we say to uppercase, and this is kind of right. And then if we say const format Pokemon, and then let's console it out, format Pokemon. And this is not even going to work because we have a TypeScript error. So even if we run it, let me just npx ts node. Oh, my bad. Let me go into cd TypeScript, and then let's run ts node. And then it's going to complain. It's like, hey, this is like any. You really need to be specific with your types. So how can we use generics here to help us out? Let me just first remove this part because it's easier to read. And if I go to the example here, we can just use generics. And of course, we're not going to use that awful name T. We're going to use something that makes sense. So let's say, for example, that we pass, like here, let's say we pass Pokemon. And then for the array, it's of course going to make sense if that's going to be an array of Pokemon, right? And for the callback, we're just going to take the singular form of whatever array we passed in, right? So it's going to be the argument when we type it out is going to be the input or Pokemon, and then we're going to use the output to return the same array, right? So for example, if we go here to map, we can say input, output, right? And then for the array, like, look how readable this is. Don't use T or those letters, right? This is a lot better. And then we can type the callback. We can give it a function parameter, right? We can say arg input. So we're going to take the singular version of whatever we passed in, right? The input. And then we're going to say that callback should return the output, right? And this is going to give us awesome autocompletion. You're going to see how. And then for the function return, we're also going to say output, but it should always return an array, right? And how awesome is this? But of course, let's also not forget, since this is an array, we also have to specify that this is an array. And all this might be confusing to you at first, and no matter how many times I explain it or show you examples, you really need to try this out yourself. And just repetition, you're going to learn a lot. And then this is all going to make sense. And you're going to know in what situations you have to use this. So please follow along, open the TypeScript playground or whatever, and let it just sink in and give it some time to process, because generics are they're really not easy to understand at first, unless you're familiar with them from before. Okay, so let me just delete this line and show you how insane this is. So let's also get some auto formatting if I save it, so it's more readable. And then if we log it out, so if we say Pokemon, it's going to infer that this is an array of string. How awesome is that? But this isn't the craziest part. So remember how we passed in a callback, and look at this magic. So when we start using that callback, when we say Pokemon equals, look how it already knows that it's a string. It's like singular version because it's an array of strings, and then it knows, hey, Pokemon is of type string. So when you do a callback and you say Pokemon to string, you get awesome autocompletion. This is completely bonkers. So let me show you how crazier this gets, or you already see how crazy this is. But let's, for example, we have Pokemon, but maybe it's not just a simple array, right? So it's an array of objects, and we can have name Bulbasaur. Of course, typing is hard, so forgive me. Yeah, we can say Bulbasaur, Charmander, Squirtle. So I'm just showing you that you can like pass it anything you want and it's going to know what it is. This is so insane. So if you say Pokemon, I mean map, and then you say Pokemon, look, oh my god, it knows the type. How crazy is that? And then when you give it a callback, you can say Pokemon and it knows the type. Name, boom, 2 uppercase. How crazy is that? That is just insane. And of course, if you're using an interface, let me just say interface Pokemon. And if we say that it has a name that's a string, and let's just give it a type. So you can say Pokemon. And then again, if you type map, Pokemon is going to infer the type, which we just passed in, right? So it's Pokemon. And then again, callback Pokemon, and it's known that it's singular Pokemon of that type. So you're going to say name, right? Name to uppercase. How awesome is this? Let me show you generic interfaces. You already had a glimpse of it, so let me just remove this. Let's say we want to have a dictionary, right? So we can say dictionary, and then we can pass in a generic. We can say type, and remember our object index properties. We can say key is going to be string, and it's going to be that type, right? Whatever we passed in. And then let's create an interface Pokemon. We're going to have a name, which is going to be string. HP, number, Pokemon type is going to be a string. And then let's say, for example, we have a consumable. Imagine this is some Pokemon game, right? Name, string, amount, number. So now if you look at this example, we can create 2 different dictionaries based on this type. So we can say, for example, const Pokemon is going to be a generic dictionary, and then we can pass the type what we want. We want it to be Pokemon. And then if you press equals, we can autocomplete it, right? Say name Bulbasaur, say HP 45. Look at this autocompletion working for us. We can say grass. And then let me just copy this over. Yeah, so let me just go here. Let's say 2. Going to say Charmander, and my typing is on point today. Bulbasaur, we can say 39. It's all the excitement because of generics, right? That's how I'm excited about generics. Yeah, so we can say 44. Squirtle, and then let's give it 3. And yeah, so now we've constrained this relationship or the contract with using TypeScript generics for interfaces. Then we can say const consumables. We can again use the dictionary generic, and now we can type in consumable. Again, just imagine, generics are like functions, just pass an argument. And then again, we're going to say name, antidote, mount 4. Let's just copy this over. So we can say that this is 2 potion, mount 8. This is 2 elixir, 3. And that's it. Let's take a look at another example, which is going to be more useful. This was honestly whatever, just so I can show you an example how you can pass this to an interface. But generic constraints are something awesome, and you might use this a lot and have a lot of use cases for it. So far we've seen generics that work with any kind of value, but we can use a constraint to limit what a type parameter can accept. So imagine if you had a Pokemon object and it has some ability, I don't know, you can use a generic and you can say, hey, only Pokemon with this ability can be passed as an argument here. So let's see how that looks like. So in this example, I have a length interface because every array has a length property on it, right? So we can say interface length, and then for the length, we can say it's a number, and we can say function item length, and let me just type it out. Return item length. So now we can add the types. So to add a generic, we can just call it type. But now to limit what you can pass to the generic, you can use extends length. And whatever you pass in now has to have the length property, which is really awesome. So let's also say that this is a generic. And now we can see how this works in practice. So we can say, oops, not here. Say const Pokemon array length. And you can say item length, and then you can pass in an array. For example, let's just use Bulbasaur. Again, typing is hard. And this is perfectly fine. So you can say single Pokemon length. You can say item length, so we can just pass a string. This is perfectly fine. And let's see how we're protected. Type safety, OP. Say item length. Just move this. If we type in 1, it's going to be an error. Argument of type number is not assignable to parameter of type length. And this is really awesome. And then we can even log it out. Pokemon array length. Single Pokemon length. Number length. Yeah, let's save this. Actually, let me comment this out so we don't get an error. And then let's run it. And everything should work fine or not. Let me just see. Number length. Oh, because I am a genius. Yeah, so you can just go here. Let's run it again. If you don't know, you can press Ctrl L so you can clear your terminal. Pro tip right there. And then we can see this works just fine. So let's look at another example that shows a sort Pokemon function that uses a generic constraint to constrain the shape of the Pokemon argument to the Pokemon interface. So let me just close this because we don't need it. Delete all this. We can say interface Pokemon. Let's give it a name string. HP is going to be number. We're going to have a stat, which is going to be HP. And then let's say sort Pokemon. And before, I'll just give it arguments stat. And then we're going to say return Pokemon sort, right? And then the sort function accepts the first element, second element. Then we can say second element, the stat we passed in, minus the first element, and also the stat we passed in. So before we type it out, let's just create a Pokemon object, const Pokemon, and then you can say, hey, this is an array of Pokemon, and this is going to be an array, right? So let's give it a name, Charmander. It's going to have 39 HP, and then let me just copy this over, so we can create two more. Yeah, I just do this, so we can say Charmeleon, 58, 78 for Charizard. And then even at the end, we can say console log sort Pokemon, and this is how you want to use it. So you want to say sort Pokemon, we want to pass it an array of Pokemon or whatever, and we want to say to TypeScript or whatever our function it is, we want to say, hey, I want you to sort this by HP. And this is going to work, but how do we type this out, right, using generics? So if we look at here, so let's look how we can constrain the shape to only accept the type Pokemon. So if you look at sort Pokemon, to type this out, of course, we're going to use a generic. our trusty pointy boys, we can say type extends Pokemon. It has to have a name and HP properties, right? And then for Pokemon, we can, let me just put it on a new line so it's easier to read. Also this, we can say Pokemon is going to be whatever the type is, an array. And then for the stat, we're going to give it a stat, right? And then for the return type, of course, it's going to return an array of Pokemon. And of course, you're probably yelling at me, not state, because it has to be stat, right? And that's really awesome. So again, if we go sort Pokemon, we get our awesome auto-completion, we can pass in the Pokemon. And for the stat, there could be only one option, we can say HP. And that's really awesome. So let's look at an example of generic constraints using type parameters. So in situations where we want to know if properties on an object we're trying to access exist, we can use the keyof operator. So first let's look at an example of this in JavaScript. So for example, if we have an object Pokemon, say HP 35, we can say name Pikachu, right? Pokemon type is going to be electric. So in JavaScript we can do, let me see, console log object keys, right? And then we can say Pokemon, and this should return our object keys. So if I go here, XDS node, this should return the keys, HP name Pokemon type. So we can do the type equivalent in TypeScript of this to make sure the properties we want to access exist using the syntax key extends keyof type syntax, which we're going to look at this example right here. So let me just close this, and then we can say function get property, and let me just give it an object and key, and it's going to return object key, right? So let's create an object Pokemon again, name Pikachu, and then we can say Pokemon type again, and then we can say get property Pokemon HP again, and then this should also fail if we say get property Pokemon, oops, because it doesn't exist, right? But so far we don't get any type safety. So this is really awesome. So we can use a generic again. We can say type and then another generic key. We can say that that key has to extend keyof type, right? So it's going to work with any of these keys we passed in. It has to have them, right? So it has to satisfy that contract. And then for the object, we can type it as type. And for the key is going to be key, and then let me just save this, and then you can say we get awesome auto-completion. So again, let me just go over that. We can say get property, and then we can pass it Pokemon, awesome auto-completion, right? It can be HP, name, or Pokemon type. So we can say HP, and then if we use another one that doesn't exist, we can say Pokemon, oops, and then TypeScript is going to complain. It's going to be like, hey, are you drunk? Argument of type oops is not assignable to parameter of type HP, name Pokemon, type any. And this is really awesome. So if you're typing something out and you don't know what's going to be passed ahead of time, then it's a perfect use case for generics.